Hi everyone, this is Nihar sir. So we will continue chapter 1, that is simple stress and strain. So in this chapter, the next topic is deformation of a body due to force acting on it. Due to force acting on it. Due to force acting on it. So let P equal to force or load applied to a body. Next, small l, original length of body. A cross-sectional area of body. Then sigma, stress induced in a body. Then epsilon equal to strain, capital E, that is Young's modulus of material. Young's modulus of material. Then del L equal to deformation of a so here is the unknown terms, that is P, force or load applied on the body, L, original length of the body, A, cross sectional area of the body, sigma, that is stress induced in the body. Previous class we have studied about stress and different types of stress, that is epsilon, strain or types of strain. In the previous chapter we have studied. E, Young's modulus we have studied in the previous class. Then del L, the deformation of the body. Now derive what is the deformation of a body. We know that stress sigma equal to P by A. In the stress topic we know that stress sigma equal to P by A and strain epsilon equal to del L by L. Stress sigma equal to P by A, strain epsilon equal to del L by A, changing length by original length. Also we know that capital E, that is Young's modulus equal to stress by strain, or you can say what is equal to stress equal to P by A, and what is equal to strain, del L by L. Next equal to P by A into L by del L, E equal to. So we have to calculate the deformation, that is del L. Del L equal to P L by A capital E, which is the required formula for deformation. So del L equal to P L by A E. Del L is the deformation, P is the force or load applied, L is the original length of the body, A is the cross sectional area of the body, and capital is the Young's modulus of the material. Basing upon this formula, let's do some problems. I am giving this formula here. So on deformation of a body, write the question. A hollow cylinder 2 meters long has an outside diameter 50 mm and inside diameter 30 mm. If the cylinder is carrying a load of 25 kilonewton, then find the stress in the cylinder, B, the deformation of the cylinder, if the modulus of elasticity for the cylinder material is 100 gigapascal. So write down the question. A hollow cylinder 2 meter long has an outside diameter 50 mm and inside diameter 30 mm. If the cylinder is carrying a load of 25 kilonewton, find first A, the stress in the cylinder, and B, deformation of the cylinder with the modulus of elasticity for the cylinder material is 100 gigapascal. So, solution. First write given data. What are the data given? A hollow cylinder 2 meter long, that means the length L equal to 2 meter. Outside diameter 50 mm, that means capital D is equal to 50 mm, and inside diameter 30 mm, small d equal to 30 mm. If the cylinder is carrying a load of 25 kilonewton, that means P equal to 25 kilonewton. Then find A, the stress in the cylinder, stress that means sigma, and B, the deformation of the cylinder, that means del L. Modulus of elasticity for the cylinder material 100 gigapascal. Here is capital E is given. Capital E is equal to 100 gigapascal. 100 gigapascal. So after writing the given data, you will make all the units into same units. So here meter, millimeter, so convert it into millimeter. 2 meter equal to 2 into 10 to the 3 millimeter. This is millimeter, kilonewton. So 25 into 10 to the 3 Newton. Kilo means 10 to the 3. So complete now. A. In A, what is the stress in the cylinder? We know that stress, sigma equal to P by A. That is equal to P is 25 into 10 to the 3 by A. That means cross sectional area. As it is a hollow cylinder, it is a hollow cylinder, that is the outside dia and this is the inside dia. Outside diameter is 50 mm and inside diameter is 30 mm. So what is the area in case of hollow cylinder? Pi by 4 capital D square minus small d square. That is pi by 4 capital D means 50 square minus small d means 30 square. 50 square minus 30 square or equal to stress. We will calculate in calculator. Stress sigma equal to 19.894. 19.894 Newton per millimeter square. Unit is very important, so you have to write unit always. So stress sigma equal to P by A. So here is answer sigma or stress unit, right? First we will calculate the stress. Now we have to go to the second part. In the second part, it has been asked the deformation, that is del L B. So deformation del L equal to del L formula PL by AE. That is, what is P? P is 25 into 10 to the power 3 into L. L is 2 into 10 to the power 3. PL by A, cross sectional area. That means pi by 4 into capital D square, that is 50 square, minus small d square, that is 30 square. A into capital E. What is capital E? 100 gigapascal. We have to convert this gigapascal into Newton per millimeter square. So 100 gigapascal means 100 into 10 to the power 9 Pascal, or equal to 100 into 10 to the power 9 into 10 to the power minus 6 or equal to 6 Newton or millimeter square, or equal to 100 9 minus 6 30 9 minus 6 is 3, that is 10 to the power 10 to the 5 Newton per millimeter square. So here is E. So below E is 10 to the power 5. So calculate in the calculator, then you can find 0.397 mm. This is del L or deformation. So in this question, the first part, it will ask the stress. We have now stress equal to force per area. Force is given, area is, as it is a hollow cylinder, its area is pi by 4 capital D square minus small d square. In the second part, it is asked about the deformation. The deformation formula del L equal to PL by AE. PL by AE. So putting the formula, we can answer. This is our question, and you will be solved many problems from RS2 or RKS2. Many problems. Question will be asked semester. Some question will be asked from this chapter. In the previous class, we have studied types of strain. That means lateral strain, primary strain or linear strain, secondary strain or lateral strain, and volumetric strain. So now we will discuss another term, that is Poisson's ratio. Poisson's ratio. Poisson's ratio, that means not Poisson actually, it is the name of the scientist. Poisson's ratio, that is 1 by m, or you can say mu. 1 by m, or you can say mu. So what is Poisson's ratio? What is its definition? Poisson ratio, it has been experimentally found that when a body is stressed within its elastic limit, the lateral strain bears a constant ratio to the linear strain. Within its elastic limit, when a body is stressed, the lateral strain bears a constant ratio with the linear strain. Or in other words, the ratio of lateral strain to the linear strain is known as Poisson's ratio. Right? Definition of Poisson's ratio. It has been experimentally found that when a body is stressed, within its elastic limit, the lateral strain bears a constant ratio to the linear strain. Or in other words, the ratio of lateral strain to linear strain is known as Poisson's ratio. Is known as Poisson's ratio. Next, it is denoted by 1 by m, or you can say mu. So mathematically 1 by m or mu equal to del d by d by del L by L. When the formula comes, make it a box. 1 by 1 or del mu equal to del d by d by del L by L. Where 1 by m or mu, you know that is Poisson's ratio. Next, del d by d equal to lateral strain, we have studied earlier, and del L by L equal to linear strain. This also we have studied earlier. So this is total Poisson's ratio. What is about Poisson's ratio? It is the ratio of lateral strain to the linear strain. Poisson's ratio symbol 1 by m or mu. In mathematical formula, 1 by m or mu equal to del d by d divided by del L by L. Where 1 by m or mu equal to Poisson's ratio and del d by d equal to lateral strain, del L by equal to linear strain. Another note point, the value of 1 by m or mu is 0.001 0.25 to 0.3. Low one layer mu is 0.25 to 0.3, and it has no unity. It has no unity. Write down this. After Poisson's ratio, your next term is bulk modulus. Bulk modulus. Symbol is K. Bulk modulus, that is symbol is K. It is also a constant. So what is the definition of bulk modulus? When a body is subjected to three mutually perpendicular stresses, when a body is subjected to three mutually perpendicular stresses of equal intensity, then the ratio of direct stress to the volumetric strain is known as bulk modulus. The ratio of direct stress to the volumetric strain is known as bulk modulus. So write the definition of bulk modulus. When a body is subjected to three mutually perpendicular stresses of equal intensity, three mutually perpendicular stresses of equal intensity, the ratio of direct stress, or you can say normal stress, direct stress or normal stress to the volumetric strength, is known as bulk modulus. Is known as bulk modulus, or you can say K. Mathematically, K equal to sigma pi del V by V. Del V by V. Where K equal to bulk modulus, sigma equal to stress, and del V by V equal to volumetric strain. This is bulk modulus. K units, SI units, Pascal, Newton per meter square, Newton per millimeter square. Stress unit of stress is same, bulk modulus unit is also same. What is bulk modulus? When the three mutually perpendicular stresses acts upon a body, then the ratio of direct stress to the volumetric strain is known as the bulk modulus, or K. So down, write down this. Next on shear stress. Shear stress. This is the symbol of shear stress. What is shear stress? When a section is subjected to two equal and opposite forces, which are tangentially which acts tangentially, as a result of which the body tends to shear off. When two equal and opposite forces acts tangentially on a body, as a result of which the body tends to shear off, the stress induced is known as shear stress. It is denoted by tau. Write down the definition. When a section is subjected to two equal and opposite forces, acts tangentially to the resisting section, the body tends to shear off. The stress induced is known as shear stress. The stress induced is known as shear stress. Second, it is denoted by tau. Tau. Third, mathematically tau equal to P by area of resisting, where tau equal to shear stress and P equal to force applied resisting area resisting, and unit Newton per meter square, Newton per millimeter square, or Pascal. Same unit as in case of stress, that is same unit. What is shear stress? When two equal and opposite forces acts tangentially, not horizontal or vertical, that is tangential, shear stress. If two equal and opposite forces acts tangentially, then the body tends to shear off tangentially. So the stress induced is known as shear stress. Not all. Shear stress denoted by tau equal to P by area of resistance. Unit is same in case of stress. After shear stress, next term is your shear strength. If shear stress is there, then is also strength. The strength. So shear strength. What is shear strength? The strength induced due to that of shear stress is known as shear strain. The strain induced due to that of shear stress is known as shear strain. Shear strain is about 5. It is denoted by 5. It is unitless. We know that strain is unitless, so shear strain is also unitless. No doubt. The strain induced due to that of shear stress is known as shear strain. Now, the last constant, that is shear modulus. Shear modulus, or you can say modulus of rigidity. Modulus of rigidity. Symbol C, or you can write G. C or G. Modulus, shear modulus or modulus of rigidity. What is definition? It has been experimentally found that within its elastic limit, the shear stress is directly proportional to the shear strain. This is shear modulus. It states that within the elastic limit of material, the shear stress is proportional to the shear strain. Shear stress is proportional to the shear strain. Within its elastic limit, the shear stress is proportional to the shear strain. It is denoted by C or G. Mathematically, shear stress means tau, directly proportional to shear strain, that means phi. So if we equalize it, then a constant comes. So tau equal to a constant G into phi, or that implies G or C equal to tau by phi. G or C equal to tau by phi. This G or C is right where G or C equal to modulus of rigidity, tau equal to shear stress, and phi equal to shear strain. What is shear modulus rigidity? Within its elastic limit, the shear stress is directly proportional to the shear strain. So, shear stress tau, that is shear strain, equalize one constant comes. This constant is known as modulus of rigidity equal to tau by phi. So, total we have discussed 3 constants, that is in the Hooke's law we have find Young's modulus capital E. Now in this class we have studied the bulk modulus, that is K, and now we have studied the modulus of rigidity or shear modulus, that is G or C. So there will be 3 constants, E, G and K. In the next class we will discuss the relation between these 3 constants.